Hello everyone, let me check if I'm live. I guess yes. Okay, hello everyone, a very good evening to all of you present in the session. Welcome to another exciting session of ICSE Physics Class 10. In case you are a Term 2 aspirant, Unacademy is the right place for you. You should rather go for an Unacademy subscription. Let me first introduce myself in case you're watching my sessions for the very first time. My name is Kalyan Krishna Awasthi and I'm your physics educator. As far as my qualifications are concerned, I have done my BTech, MTech in electronics, and right now I'm pursuing my Ph.D in electronics as well. Okay, with my area of specialization as wireless sensor networks. This is what we're going to cover in this particular session. We are going to cover resonance conditions, the loudness, pitch, and intensity. And students, this happens to be my YT code. Kalyan Live. Let me write it here. It might be clipped off due to my pic. This is my code. In case you wish to go for the subscription, you can use this code to avail 10% discount. Okay. You can use this code to avail a 10% discount. And if you are not following Unacademy Champions on Telegram, do follow it now. The link is provided in the description box of this particular video. I would request everyone to click on that link so that every time a particular session is live, in case as and when the Unacademy comes up with exciting offers that they had for the past 3 days, the Republic Day offer which ended yesterday. So you'll always be updated with all these offers, all these timings of these sessions and all the updates. So I would request all of you, in case you're watching this video, just follow Unacademy Champions on Telegram. And if you haven't subscribed us yet on the YouTube, well, this is the right time to subscribe us, because the board examinations are about to start, and in that case you'll need help in every aspect, and for that Unacademy is there. And this YT channel will also be providing you the contents related to your course. Very shortly we might have tests as well. So in case you are subscribed to the channel, it will be an added advantage. See, we are aiming for 1000 subscriptions, and in that case, I guess if you haven't subscribed us yet, this happens to be the right time. And apart from the subscription, I would like all of you to click the bell icon. As soon as you click the bell icon, you will be notified with all the upcoming sessions, all the upcoming videos. Whenever an educator goes live, you'll be sent a notification. This way, see, it's okay that a particular topic is there on the YouTube, but in case you happen to interact with the educator live, this always is an added advantage. Okay, so for that I would request everyone to subscribe us on YT, so that whenever an educator goes live, you are able to watch the session live and ask the questions then and there. Okay, in that case, just go for the YT subscription. Okay, very important announcement that we have been doing in almost every session, that the Unacademy Prodigy test is back. The test is for class 7 to 10th learners, and you get to win prizes worth rupees 10 crores. That's quite exciting. And the best part is that the enrollment for this particular test is absolutely free, and the test is happening on 4 dates. 23rd Jan, it has already happened. The next date is 29th Jan. Okay, just make a note of it. After that, the 2 dates are Feb 6 and Feb 13. The duration of the test is 1 hour, and the timings are for 12 to 1. Okay, and the best part is the enrollment is absolutely free. There's no harm in appearing for a test. You'll obviously get to learn something. Okay, and in case you are well prepared, you might win prizes as well. Okay, fine. The prizes are in the terms of hidden perks as well. You might unlock a plus subscription that will add value to your preparation. So Unacademy Prodigy is a very, very, very important platform, a very, very important test which you should rather go for in case you are a class 7 to 10 learner. Okay. Chalo, now let's start with the session. The very first thing that we have to discuss today is resonance, and precisely the condition under which a body resonates. For understanding the concept of resonance, we need to have a very basic idea of what forced vibrations are. See, we have to have a very basic idea of what forced vibrations are. If you're not able to understand what forced vibrations are, you will never be able to decode this concept. Why? Because resonance is a special case. Yes, it's a special case of forced vibrations. And what happens in forced vibrations? The body is acted upon by an external force. Just make a note of it. For example, if I'm saying that a pendulum is hanging, if in case the pendulum is hanging and it is set into motion in vacuum, in that case the vibrations will be natural. For natural vibrations, you have only restoring force. In case your pendulum is in air, in that case there will be air resistance, and I'll rather say that my motion or my vibrations are damped. And then we have third part, that is forced vibration. And resonance is a special case of forced vibration. I mean, if you want to understand resonance, you have to establish a relation between the forced vibrations and natural vibrations. See, let us take a very realistic example. For example, if a body has a tendency of moving, say, completing 3 rounds in a unit time. Just let us suppose a body completes 3 rounds in 1 second. Fine. That means 3 rounds kind of is the natural tendency of the body. Okay. Now what happens in case I apply an external force? Let us suppose we have applied an external force, and the frequency of the external force actually matches with the natural frequency of the body. I mean, you are susceptible to something, you are doing something, you are finding it great. Let us take the example of a teacher. For example, if a teacher enjoys teaching and he's given extra classes, I mean, in that case, it's not going to hamper his prospects. If time permits, if his health permits, in that case, he'll be doubly excited. I mean, he can't ask for anything else. He was a passionate teacher. He wanted to teach students. He wanted to impart education. On top of that, he was given an additional responsibility, that too with money. Now tell me, I mean, it's a win-win situation. What will happen? Obviously, the teacher will teach with more conviction. I mean, obviously, he might not be doing it that way, but yes, the amount of effort that the teacher will apply will obviously increase, no matter how much it increases or what percentage of effort he additionally imparts. But in that sense, obviously there'll be an effect. The same thing happens with the vibrating body as well. I mean, let us suppose that a body is vibrating, okay, and the body is vibrating with a natural frequency that I've set 3 rounds in 1 second. Now we apply an external force on the body, but that external force will try and force its frequency. Yes, the body will be set under forced oscillations, but the condition here is that the frequency of the external force happens to match with the natural frequency of the body. I mean, a teacher wanted to take class, he has been given an extra class, that too he'll be paid for it. What more can a teacher ask for? Yes, I mean, you wanted to go out for a movie and your father or maybe your guardians tell you, okay, you have been studying quite a while, just go out, have fun, go for a movie. I mean, see, now everyone might feel the relief. I mean, we are not stressed at all if our parents actually say what we wanted to do. This is what happens in case of resonance. I mean, everybody has a natural frequency. Now we have applied an external force on the body, and the frequency of that external force matches with the natural frequency. So what will happen? The body will be set under resonance. This condition is called resonance. See, I've written it in the very first point. When the frequency of the external force is equal to the natural frequency of the body. And what will happen? I mean, if I'm given extra classes and I'm being paid for it as well, obviously I'll be teaching with more energy. Yes. So in physics, what will happen? The amplitudes will increase. Yes. The amplitude of vibration will automatically increase. Yes. So what is the necessary condition for the for resonance? First, I mean, what are the characteristics for resonance? The very first is that the frequency of the external force should be equal to the natural frequency. This is the first condition. What's the second condition? The second condition is that the amplitude of the vibration increases. Yes. So these are two conditions for resonance. I hope you've got it. It's very easy and important as well. I mean, it does have a lot of physical significance. Okay. This is the best part. It does have a lots and lots of physical significances. Now, let's decode it with through some examples. Now, let us take this example. See, let me first demonstrate you how things are happening. We have got two tuning forks, right? Both the tuning forks are placed on two boxes in which air is filled, and the boxes are separated at a distance. I mean, not at a very large distance. What we do is we create vibrations on the first tuning fork, on this particular tuning fork. Okay, we have created vibration. I mean, we have applied a force so that this tuning fork is set into vibration. Fine. See, it will vibrate with a forced frequency. Yes. You can clearly see that this is an external force. This is an external force. As soon as I apply this external force, the body starts vibrating with the frequency of this external force. Yes. So this will be forced vibration. Yes. And the condition is that both the tuning forks are exactly identical. This is an important constraint. Both the tuning forks are exactly identical. I mean, in every respect, be shape, size, material, length, breadth, natural frequency, everything is same. Okay. Now see what happens. These vibrations, they are transferred from the box to the air which is present within this vibrating air column, and the same vibrations are transferred to the second box. Okay. Now through this second box, these vibrations, I mean these oscillations, are transferred to the second tuning fork. I mean, this was the first tuning fork, this was the second tuning fork, right? So what happens, what we observe is that after some time, I mean, when we put the tuning fork on the, let us call this as A and call B. When we put the tuning fork on this box A, what we find is the other tuning fork, that is B, it also starts vibrating and a very loud sound is heard. Now this is a catch. I mean, it does start vibrating, that's perfectly all right, but a very loud sound is heard. This is important. Loud sound is heard. Okay. And why does this happen? This happens because of resonance. Okay. The second tuning fork creates a loud sound and sets into vibration because it now resonates with the first tuning fork. The condition in this particular experiment that we have to keep in mind is that both the tuning forks should be exactly identical. I mean, we cannot have two tuning forks of different material, different shape, size and all. They have to be identical in all respect. Then only they'll be set into resonance. Okay, this is a very, very, very important condition, right? Okay, fine. Now, let us take one more example. I mean, I have not mentioned it in the slides, but let us take one more example of that pendulum. It's a very popular example. Yes, we have that very popular example. Now, see, before understanding this example, let me tell you one thing, that the frequency, the natural frequency N, it is inversely proportional to L. Okay, so you have to understand this. We have discussed this in part 1. I mean, yes, that the natural frequency is inversely proportional to L. I mean, if we are having two threads of same length, then their natural frequencies will be exactly same. That's the catch here. Okay, now let us name these lengths. Let us call it LA, LB, LC, LD. Now if I write these lengths in a decreasing order, what should I rather write? I should write LC is greater than LA, which is equal to LD, and which is greater than LB, right? Just make a note of this. This is what will happen. Yes, we have seen the order of the lengths. Okay, yes. Now let us suppose what we do, we set pendulum A into vibration. I mean, we apply an external force. Try and understand, it's very easy. We apply an external force on this pendulum A. Okay, now just take 30 seconds, and if anyone is interested, you can send me in the chat box what will happen. I mean, which particular pendulum will be set into resonance, what will happen to the amplitude of the other pendulums, and what all will happen. See what happens as soon as we apply an external force to A. See, this is an external force, so what will happen? A will be set into forced oscillations. Okay, yes, right. Now this thread through which all the pendulums are kind of connected, it should be inextensible, and it should transfer the oscillations across its length. So what will happen, first and foremost, this pendulum A had a length equal to pendulum D. See, now see, this is exactly similar to the tuning fork example. I mean, say this was box 1, it had a tuning fork 1. This was box 2, it had a tuning fork 2, and there was a medium air. See, in the previous slide we have seen there was a medium air through which the waves were transmitting, right? And the other part was set into vibration. The same thing will happen here as well. I mean, this medium will facilitate the flow of waves, and what will happen, this D will be in resonance with A. Why? Because LA is equal to LD. Since the length of both the pendulums is equal, so D will be set into oscillation with A, and this is a condition of resonance. Okay, now there's a very popular question, what will happen to the amplitude of D? See, D's amplitude will not increase immediately. It will slowly increase. It will be equal to A. I mean, see, both the bodies are in resonance. So at one particular time, they have to be at equal amplitude. Yes or no? Yes. Now, when the amplitude of D will be maximum, see, it will increase slowly. Why? Because of resonance. A peak will be achieved when the amplitude of D, I'm talking about D, just make a note of it, because these two lengths are same. I mean, this figure is not what you see in your books. Don't get confused. Okay, the figure in your books, the books that you're studying, and this particular figure is different. Okay, here LA is equal to LD. We have discussed this question in one of the special classes, and there was a lot of confusion. Why? Because I've taken a different diagram, and I've taken a different diagram intentionally, so that you don't make a habit of kind of just a rectification of everything. So that is why I have taken it a bit different. Okay, so that you understand the concept pretty well. Now what will happen, slowly and steadily D will attain a maximum value. When D will attain a maximum value, A will be at its minimum value. See, the same energy, the same power, the same amplitude has to be shared. Okay, okay, and this will keep on happening. I mean, this will be a recursive process. When D will be maximum, then A will be minimum, and vice versa. I mean, they'll keep on changing their amplitudes, right? Fine. Is it okay? Why? Because They are in same frequency, they are in same phase. That is why this happens, right? And what will happen to pendulum B and C? I mean, will they vibrate? Obviously, they will vibrate. I mean, in the last session, a student asked a question, what will happen to this pendulum B and C? These pendulum will also vibrate, and first of all, why will they vibrate? They will vibrate because the same forced frequency, the same forced vibrations are imparted and transmitted across this length. See, the same vibrations are transmitted across this length. So this particular thread, this particular pendulum will also, be acted upon by a force, but that is a forced vibration. See, the external frequency is not equal to the frequency of B. So although they will vibrate, but with a very small amplitude. Okay. So I hope this is a very popular question. They have asked in board exams as well. Every time they change the pendulum lengths, and a number of students who have just mugged up the concepts, they mess it up. Okay. So what we have to do is, whenever this type of question is asked, the very first thing that you have to focus on is you have to check the lengths of the string. Okay. Or maybe precisely the lengths of the pendulum. Whichever two pendulums are having the same length, they will resonate. Why will they resonate? Because natural frequency of a string is inversely proportional to length. Keeping all the other parameters constant, the natural frequency is inversely proportional to length. So if the length is same, then only I will say that N1 is equal to N2, right? So this is the catch in these type of questions. This is a common mistake that most of you do. And one more thing, like I guess Akshat asked in one of the sessions, sir, what will happen to pendulum B and C? Yes, pendulum B and C will also vibrate. There's no second thought about this, but their amplitude will be very, very small, very small. Okay. Why? Because they are under the influence of forced vibration. And one more thing, see the length part, the length is very large, the frequency will be less. The length is less, the frequency will be large. Okay, this is how things happen. Whenever you get a simple pendulum question, or maybe a tuning fork question, or maybe a vibration in an air column question related to this forced vibrations, what all you have to do is you just have to check the lengths. Okay. And you'll get the answer. One more problem that most of the students have, they ask, sir, why will when D will be maximum, A will be minimum, and then this energy will be again redistributed? See, both are having same frequency, but the external force had a limited energy that has to be shared. I mean, it will go like this. One is max, one is min, one is max, one is min. So what will happen? You'll see that see, if this is max, this is min, this is max, this is min. It is happening this way. So what happens? Both the pendulums move and they are set into resonance, right? I hope this is clear now, all of you. Yes, we do have an example for this, this water column as well. What you can do is, I guess I haven't taken, yes, I haven't taken that example, but it's very easy. What you can do is, if you have a tube, say a beaker, maybe, okay, and you have a tuning fork on that. So what happens? I mean, you can do it without that apparatus, I mean, which has been mentioned in your diagram. It's very logical. If you fill a bucket, I mean, we have this tendency, if we are sitting at a large distance and a bucket is being filled, so we get to know, okay, just by hearing the sound, acha, 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 now the bucket is about to fill. Yes, it does happen with everyone. हमें पता चल जाता है कि यार अब बाल्टी भरने वाली है या मे बी भर गई है. कैसे पता चलता है? बिकॉज व्हाट वी डू इज वी जस्ट एनालाइज दिस नॉइज, दिस साउंड दैट इज क्रिएटेड. यस, and that sound is not because of the water level is increasing, it is because of the vibrations of the air column. In case we put a tuning fork at the mouth of the beaker, when the frequency of the air column matches the frequency of the tuning fork, you will see that the tuning fork is set into vibration. Yes, so this is the third case. I mean, just try it at your home. Just have a bucket of water and fill it. Okay. The very first thing that I'm asking you to do is Just sit at a considerably large distance and try to analyze. I mean, it's very practical. All of us get to know that, okay, the bucket is about to be filled. Yes, it does happen that way. All of you, yes? Okay. So this is how the resonance works. I hope the concept is pretty much clear to everyone. Yes? All of you? Okay, fine. Chalo. Now, a very important thing. See, we are science students and we need mathematical proofs or validations for our results. Now, characteristics of sounds is a very abstract phenomena. If I tell you, I mean, this sound is loud, this is shrill, this is grave, this is, soft, this is hard, it's okay. I mean, you will believe because you have been hearing them for a very long time. But what is the technical part behind this? I mean, how will you get to know the technical part? For that you need mathematical proofs, and for that you need waveforms. Yes, you need waveforms. You are a future scientist. You won't believe me saying, okay, this sound is loud, this is high pitch, low pitch, whatever pitch is that. You have seen the instruments. I mean, have you seen that the waves are created? I mean, in the conventional ones, they used to have that bar. In the old tape recorders that they had, when you used to play a music, you would have seen the bar graphs going up and down. Yes, has all of you seen that? It happens. I mean, they do have these bar graphs which keep on changing their heights, lengths, and positions as the music is loud or you know shrill or maybe grave. Now, modern instruments, what they have is, if you have been to any of the DJ, I mean, any of the popular DJ show, or any of the discotheque in your city, there's a screen where you can see a graph. I mean, at times they have bars as well. Otherwise, there's a waveform. Now, what is that waveform and how it is created? See, if we wish to analyze the characteristics of a sound, we need a mathematical validation. We need a proof. For that, what we do, we use this particular arrangement. What it does, this is a CRO. CRO is a cathode ray oscilloscope. Let me brief you about this. It is a cathode ray oscilloscope. And what it does is, it creates the waveform for the input signal. Yes, it does create a waveform for the input signal. You just send a signal as the input, apply it on the Y plates of the oscilloscope. I'm not dwelling into the working part. You'll study this in your engineerings. How does this CRO do this? But what you have to know is that you are applying it on the Y plate. There are X plate, Y plates. That too is a technical aspect. When you apply these waveforms to see, this is a loudspeaker through a microphone. You have taken the signal and you have wired it. You have applied on the Y plates, and what you can see is a waveform. Now, if for a particular sound I have a waveform, now I can analyze the characteristics because I'm a science student. I mean, you are a science student. You need proofs. You want to see how a quantity is changing its value with respect to another quantity. So what happens? This particular arrangement ensures that you get a proper waveform. Okay. Now, based on these waveforms and the other parameters, we have said that sound possesses three characteristics. Okay. One is loudness. The other one is pitch or shrillness, you can call it. I mean, yes, at times in board examinations they ask shrillness, and at times they call it pitch. Then you have this quality or timbre. Fine. So first of all, let me quickly brief you about this. Okay. The best thing is, for all the plus subscribers, a new champions batch is starting. Yes, if you have been following the lectures for quite some time and you're hoping, I mean, you're planning to go for the subscription, this is the right time. Okay. For all class 10 plus subscribers, a new champions batch is starting from 1st of Feb. Yes. And since it is a champions batch, the mode of delivery here is going to be English. And the offer is still applicable. If you subscribe for ICSE class 10th, you'll be getting the subscription for 11th and 12th absolutely free. I mean, this is the best possible deal. Okay. In case I'm again repeating, you were planning, but you were thinking, okay, I have missed some classes, I want to interact with the educator live. This is the right time. From 1st of Feb, we are having our new batches. And in case you wish to enroll, you can very much use my code Kalyan Live. This is my code, okay? This is my code. If you'll be using this code, you will get 10% discount, okay? So, rush, don't miss this opportunity. The champions batch is for English delivery, for Hindi delivery. In case you wish to understand or you wish to study the concepts in Hindi, then this is the batch for you, Udan. Okay, in Udan, the content will be delivered in Hindi, and these are the faculty members who will be taking up the Udan batch. Okay, both the batches are starting from 1st of Feb 2022. Today is 28th. Okay, I mean you have 3 days. Don't miss this opportunity. I mean, you should not miss this opportunity. You have attended a number of lectures, special lectures and YT lectures for almost every educator by now. So this is the right time. You might have made your mind to go about it. So don't miss this opportunity. Go for it, right? Now, what I was telling you, we were discussing about the 3 fundamental qualities and characteristics rather, loudness, and pitch and quality. Now see, what is loudness? I mean, if I try to explain it in a layman language, I mean, if I go about the non-technical part, I mean, we can easily identify a loud sound and a fade sound. Yes, all of you can do. I mean, yes, you can identify a loud sound and a fade sound, right? But what is the technical part? See, let us suppose there are two sounds which have same pitch and quality. So see, whenever you are analyzing a particular characteristic, there is an assumption. I mean, if we are talking about loudness, then we have to assume that pitch and quality are constant. Just make it a note. I mean, otherwise you'll be damn confused. So whenever you are analyzing any characteristic of a sound, you have to assume, I mean, yes, at pure level, you have to assume that the other two are constant, okay? Whether or not it is mentioned in the question, but it is understood. I mean, if I'm talking about pitch, then quality and loudness have to be same. If I'm talking about quality, then pitch and loudness have to be same, right? Yes, all of you? Now see what loudness is. I mean, if I'm speaking like this is loudness, yes? I mean, this voice is different from my normal voice, yes? And did I do some extra effort? Yes, I did. I mean, I have to do that extra effort. I have to apply a lot of force on my throat, on my epiglottis to produce this loud sound. Yes? Yes? And if I'm producing that extra, I'm doing that extra effort, obviously the amplitude will be greater. Yes? This is what happens in loudness. In loudness, the force, the efforts have to be increased. Yes? And because of those increased efforts, the amplitude is greater. Okay? So in loudness, we have greater amplitudes. Fine? So if somebody asks us, how will you identify whether a sound is loud, whether a sound is quiet? So what will you tell? I mean, if a loud sound is created, the source has to make that extra effort. Yes? And that extra effort transforms into the amplitude part. Okay? That extra effort transforms into the amplitude part. You can clearly see the two waveforms. This is waveform 1, this is waveform 2. What is the difference between the two waveforms? See, if I draw a reference line, let us suppose this is a reference line. See, this is A1, amplitude 1. This is minus A1. This is A2. And this is minus A2. You can clearly see that A2 is greater than A1. So what loudness does is, loudness helps us to relate the amplitude of the signal. Greater the amplitude, greater the loudness. Okay, loudness is proportional to amplitude. Okay, we'll get to know the mathematical part as well. I mean, whether it is, Technically speaking, it is proportional to the amplitude square, but I was just talking about the relation. So loudness does depend on the amplitude, and it is directly proportional to the square of the amplitude. Okay, right? It is proportional to the square of the amplitude. Now, what are the factors that affect the loudness? The very first thing is, I've already told you that loudness is directly proportional to the square of the amplitude, and it does depend on the distance as well. Yes, it does depend on the distance as well. If I say L is proportional to A square, L is proportional to 1 upon say D square. See, if a sound source is placed at a very large distance, okay, obviously no matter how loud the sound it creates, the amplitude, or maybe you will not be hearing that sound quite loud. If I start shouting the way I was shouting a while ago, and I shout from this particular point, obviously the sound that will reach you will be a little weaker. I mean, in amplitude wise, it will be little less. Yes, so distance is an important parameter as well. Loudness is directly proportional to the surface area of the vibrating body. Yes, it again is a very important parameter. See what happens if I, create a sound by, hitting my mobile, and then I create a sound by hitting this pen tab. You'll obviously see the constraint is that both the sounds should be produced with the same intensity. I mean, the driving force should be same. So what will you notice? The body that has greater surface area produces a greater sound. I mean, the loudness is more. Okay, okay, the loudness is more. Obviously, see, if I hit this table on which I'm sitting, on which I've placed my laptop, this table will create a greater noise. I mean, you'll hear the sound louder than ever. Why? Because the surface area is greater. A number of molecules, a number of, the greater surface area is in contact, is affected, and it produces more vibrations. Fine. Loudness is greater. Obviously, for dense mediums it will be greater. Why? Because dense mediums, the molecules, the particles are tightly bound, they are very closely attached to each other, and these disturbances, they travel quite rapidly. Let me consider, I mean, a disturbance is produced here and the other molecule is here. I mean, there will be some time. I mean, the disturbance, the wave will take some time to reach here, and meanwhile it will lose energy. From here to here, again it will lose energy. So the amplitude will keep on decreasing. On the contrary, if they are jam packed, what will happen? I mean, instantly the disturbances will be transmitted, and what will you notice? You'll notice a very loud sound. Yes. The last part is the dependence of loudness on the resonant body. Yes, obviously. I mean, if a body is present around a body on which the external force is applied, and the natural frequencies of the two body are same, then obviously it will happen that both the bodies will resonate and a greater amplitude will be generated, and we'll call it a loud noise. Yes, all of you? I hope you're getting this, all of you. Okay, now one more thing. Intensity. Now this is different. See, if I'm sounding loud to you, I might not sound loud to someone else who's standing at a very large distance. So what I mean to say is that loudness is a very subjective term. It depends from person to person. I mean, I might be good for you, but I might be very bad for Mr. X. Yes. Why? Because my nature is subjective. I'm not good to everyone. The same thing happens with the sound as well. A sound might not be loud for everyone. For me, a sound might be loud. For my brother, for my sisters, the sound might not be loud. Okay, but in science we need to objectify things, right? I mean, I need to attach a particular parameter, a particular value that could define the property of the sound that is created, and that particular parameter is intensity. Okay, fine. And on what parameter does it depend? It depends upon the amount of sound energy passing per second normally. I mean, if I wish to write the intensity, amount of sound energy passing through a unit area into per second. Fine. So this happens to be the formula for intensity. Let me write it here. This happens to be the formula for intensity. Yes. Now, if I talk about the unit of it, what is the unit of energy? Energy is joule. Yes. Area is meter square. This is second. Fine. Fine. And what is joule per second? Joule per second is nothing but watt. Yes, it is watt. So what, I mean, not WHAT, it's WATT, watt. So my unit for intensity would rather be watt per meter square. Yes. Hi everyone who has joined the session right now. Hope you're doing well, guys. Right. So this is how we find the unit of the physical quantities. Yes. Now see, if I say that the intensity of a particular sound is, say, X. Now this X is a objective term. It will not change its value, not at all. So it will remain X no matter where I am, no matter who I am, and no matter how far I am standing from a sound source. This intensity property is objective to a particular source. It is fixed. I mean, it cannot change either. Okay. So this is the difference between loudness and intensity. A number of times students get confused. If a if a sound is intense, that means it is carrying a very, very large amount of energy. Okay. If a sound is loud, it means the amplitude is very large. The energy might not be large, but the amplitude is large. I mean, for me, the amplitude might be large, but for him, the amplitude might not be large. So loudness is a very subjective term, whereas intensity is an objective term, right? I hope you've understood this. That's very important. Now let me quickly brief you about this Unacademy subscription feature. I mean, if you're looking for, we will be doing quizzes as well. I mean, once the session ends, before the end of the session, we'll be doing 3-4 questions as well. So in case you're following the session, you're live. I mean, I cannot see you and you're not replying either. Whoever is there in the session, just stay and see what all questions we have to discuss. So I was telling you about the Unacademy subscription feature. See, these two are very, I mean, well known. Why? Because you get to learn at your comfort from your home, and that too unlimited number of times. Yes, you get to learn at your comfort from your home unlimited number of times, that too from the top educators. I mean, what more can you ask for? You're getting the education through the top educators at your home live and unlimited access. And on top of that, for every plus subscriber, the fourth session, I mean, every fourth session is a doubt clearing session. This every fourth session is a doubt clearing session. You attend the 3 classes, whatever the educator is teaching you in the 4th class. In case you have any doubt, you can clear all your doubts, or rather the educator will, obviously, I mean, we all do this in the doubt session. We do a lot of questions, lots of questions. Okay, so you have that added advantage as well. Okay, and the best part is you get the coverage, the exhaustive coverage, the entire content, the entire syllabus is covered. These are the mentorship and guidance options as well. And there are a number of practice tests, live test series, and the courses are bifurcated as per batches. I mean, it's not that you won't find your batch. You will find your batch. Maybe class 7th, 8th, 9th, 10th, whatever class you are in, you'll definitely find a batch for yourself. Okay, and in case you wish to subscribe, don't forget my code. This is my code, Kalyan Live, right? This is my code. If you'll be using this code, you will get 10% instant discount, right? On whatever pricing it's being offered, you'll be getting 10% over and above. Now see the pricing. I mean, you'll be shocked to see the pricing part. For 6 months subscription, the pricing is only 1,500 per month. I mean, that's very competitive, very competitive. I mean, you get to study physics, chemistry, maths, bio, everything in 1,500 rupees per month. If you're a class 9th or 10th student, and if you divide 1,500 by 4, you'll get to know, I mean, it's less than 400, right? I mean, in less than 400 rupees, you are being taught from the top educators of the India at your home, at your convenience, with all the doubts being resolved. Fine. And the best part is, as you move on, I mean, if you're opting for a higher duration, the per month price keeps on dropping. Just see. I mean, for a 48-month subscription, you'll you'll be shelling only 750 rupees. And on top of that, if you'll be using this code Kalyan Live, you'll be getting additional 10% discount. I mean, 750 minus 10% is 75 rupees will further be deducted. I mean, this is the best you can have. Okay, so don't miss this opportunity. The offer is not going to stay for a very long time. I mean, the prices are very competitive. You should rather go with it. Okay, these are the details for all my upcoming special classes. In case you are not sure, you want to check it out. I mean, how does and the portal look like? See, this is a YT session. This is not the Unacademy portal. So you should rather go and try once for the Unacademy portal. I mean, you'll be shocked to see the quality. You'll be shocked to see the features. See, these classes are already over. The next class is on 29 Jan. I mean, tomorrow. See, in case you are watching this session, you have watched these slides, you have seen this content. The same content will be delivered tomorrow again in these special classes, and you'll get to see the difference. Okay, you'll get to see the difference. And the best part, I mean, if you are a class 10 student, don't forget to enroll for this class on 31st Jan. I mean, it is a review of current, electricity and magnetism. You're free to ask any question you want to ask related to current, electricity and magnetism. I mean, this is going to be the best test for you. I mean, just if you are not sure about the quality of the education that has been imparted, if you have doubt on the credibility of the educators, just enroll for this class and ask whatever you want to ask. I mean, obviously of class 10, whatever you want to ask. I mean, from current, electricity and magnetism, clear all your doubts, all your damn doubts. Okay, so this is a great opportunity for all of you to see. And see, the class is on 31st of Jan, 6:30 p.m. The new batch is starting from 1st of Feb. So you have 12 hours to decide. I mean, if you're not sure, just enroll for these. See, 2 classes are left. One is tomorrow and then on Monday. Attend those classes and see if you want the plus subscription. And let me assure you, whatever you are watching on YT or special classes is just 40. I mean, YT is just 25 to 30% of what we deliver in the plus classes. Okay, it's just a trailer. If you wish to watch the extended trailer, go for the special class, and for the entire movie, we have that plus slot for you at such a reasonable price. I mean, they have just started with the K-12 series. You won't be finding these prices for a very long time. I mean, this is very easy. I mean, very affordable. Just take a snap of this particular sheet. Don't forget to enroll for these 2 classes. It will definitely change your perception for Unacademy. You'll get to see the quality that we'll be providing. Okay, I mean, this is going to be a game changer for you. The offers will not be this way for a very long time. We have just into this K-12 and we won't be giving these offers for a very long time. So it's the right time. And this, again, let me repeat, this happens to be my code. If you wish to go for it, just use this code and avail 10% discount. Okay, that is the best part. Now let me tell you the special features of the special class. I mean, this striking features. In special classes, we have a number of polls. Fine. See, and apart from having polls, we have a leaderboard as well. I mean, as soon as the polls end, a particular poll ends, you get to see your performance. I mean, see, out of 3 questions, these students were they replied all the questions correctly. And the best part is, in order to judge your performance, 2 parameters are important. I always tell this to my students. I mean, accuracy is the must, but not only accuracy. If the speed is not good, you're not going to go anywhere. Okay, in this cutthroat competition, accuracy and speed, there has to be a trade-off between both these parameters. I mean, just being accurate will take you nowhere, and just having a very high speed with minimum accuracy is again going to hamper your prospects. So there has to be a trade-off between accuracy and speed, and these polls at the special and the plus classes they help you maintain that trade-off. I mean, you get to know how accurate you are and how quickly this accuracy came. This is the best part. See, you can clearly see the time frame. See, 0.2 second. CAF's average reply time is 0.2 second, right? So this is a great chance for you. And on top of that, we are having this doubt clearing session as well. I mean, while you are attending a special class, in case you have a doubt, live in the class you have the chance to ask the doubt. See, once you click on this, a tab opens, and in this particular tab you can type your question. In case you're finding something different in your book, just attach the file and send. Okay, this way you will be benefited. And if you are on YT and you haven't I mean, you don't know much about these special classes, let me guide you through how to attend my special classes. What you have to do is just download the Unacademy's learner app, click on the get started, continue. I mean, just enter your 10-digit mobile number, write your name. You'll be directed to this page. Click on class 6 to 12. Obviously you must be a K-12 student, and write the goal, ICSE, ISC, 9, 10th, whatever goal you are striving for. And in case you're comfortable with English, I mean, see, being an ICSE student, if you want to go about go for English, I mean, I must say that you should rather go for English. Then just click on it and click next. Okay, it will direct you. See, the description box has the link for my special class. Okay, click on that, click on the notify me part. You'll be notified 10 minutes before. Okay, and once you download the Unacademy class app, you want to see my special classes, just use this code. I mean, once you use this code, my special classes will be unlocked. Okay, with this code, my special classes will be unlocked, and you'll get to see all the special classes, and then decide whether to go for the plus subscription or not. Now let's see the next part. Okay, the next, see, we were supposed to discuss 3 parts. One is done, 2 are left. One is pitch. What is pitch? See, this loudness was related to the amplitude, and pitch is related to the frequency. I mean, if the frequency is high, we call it shrill. Like Hindi mein you call it patli awaaz. I mean, I hope you are able to understand. This voice in which I'm speaking, this is shrill. Okay, this is shrill. This is high pitch. And on top of that, if I say that frequency is important, this is grave. Okay, so the modulation in my voice is not because of the loudness. I mean, the amplitude in both the cases is same. Only what I'm trying to do is I'm changing the pitch of the sound. Yes, you've understood that. So this is pitch. Okay, I mean, you must have encountered this in different musical instruments. The musicians, they do have, you know, wires. So maybe they in guitar they tighten the wire to change the values. I mean, see, what they do is the frequency is 1 upon 2L under root P by M. Now if you tight the screw, what will happen? The tension in the wire increases. Yes, obviously. I mean, see, if you are tightening the screw, the wire becomes more and more tight, and when it is very tight, the tension is very high. When the tension is very high, what you say is that the value of N is high, the frequency becomes high. Okay, so this is how the musician go about the change in the tone. Okay, so higher pitch means higher frequency, lower pitch means lower frequency. See, you can clearly see the difference. There are a number of vibrations in a single time period. If I start from A to be, if I take one time period or maybe this entire duration, you will be seeing a number of waveforms in graph 2. So it is a higher pitch diagram. Okay. Now let's talk about the quality. What is quality? I mean, if I, I mean, if I play two songs, I mean, a single song by two different musicians. I mean, for example, Zubeen Nautiyal is singing a song, and the same song is sung by Arijit Singh as well. Now, even in your wildest dreams, you will be instantly able to identify Arijit's voice and obviously Zubeen's voice. Yes, although the same song is played, the same music is there, the same arrangement is there, everything is same, but still you will be able to identify that okay, this song has been sung by Arjit Singh and this song by Zubeen Nautiyal. Yes, it does happen that way, all of you. I just need a thumbs up if you're understanding this. Now see, this is quality. This is quality or timbre. Okay. Like I said earlier as well, whenever we are addressing a particular property of sound, the other two properties have to be assumed constant. If I'm talking about quality, it automatically means that the pitch and the loudness are constant. Okay. Don't have to worry about it. So never ever, I mean, don't get confused. Never overthink on that. I should rather say, don't overthink that, okay, quality is there. So what about pitch and all? So everything else will be assumed constant. Now see, the problem is, in fact, not the problem. Just by looking at the waveform, you can tell the quality. See, now let me summarize this. And before doing the questions, let me summarize the very first thing that you have studied is loudness. The loudness was all about the amplitude. Okay, it was all about the amplitude. Then we had pitch. The pitch was all about the frequency part. And then you had the quality or timbre. This was about the waveform. Okay, so these three characteristics are associated with these three characteristics of the sound. I mean, these three parameters, these three technical aspects are related to three different characteristics of sound. Okay, I mean, loudness is for amplitude, pitch is to frequency, and quality is to waveform, right? Now let's see if you can do these questions. They're very easy. I'm giving you 30 seconds. The first question says, the most salient features of any vibration are. Just go through the question. I'm giving you 30 seconds. Not at all difficult. I mean, if you have watched the session properly, it's very, very, very easy for all of you. Just take your time, 30 seconds, and if you wish, you can send me the correct answer on the chat box. I'll get to know if you have replied. It's very easy. We have just studied all the properties. I mean, it's not that all difficult. Okay, it's not at all difficult. Just go about it. It's very, very, very easy. See, acceleration is out of question. I mean, so obviously these two options cannot be correct, and amplitude and frequency has to be the correct answer. For amplitude, you had loudness. For frequency, you had pitch. Okay, so we have these two options, amplitude and frequency. Amplitude is for loudness, frequency is for pitch. So C option has to be the correct one. Second, types of vibrations. I mean, that's very easy, very easy. We have discussed this in the previous session as well. Anyone see there are three kinds of vibrations. A free is often called as the natural. Okay, then you have this damped vibration, and then you have this forced vibration. So I guess option C has to be the correct option. Okay, yes. Natural vibrations, you have only restoring force. Damped vibration, you have got restoring. plus resistive, and then you have restoring plus resistive plus external force. Yes, so this is what we go about this. Okay, I hope this is all for today's session, for the today's YT session. Thanks for being there. I hope you've found the session interesting. I've tried my level best to make it as interesting as possible. I've already given you a quick recap on that. So, well, if you haven't downloaded the Unacademy app now, just download it from the Google Play Store or maybe App Store, the Apple App Store. Fine. You can try all these features absolutely free, and yes, don't forget to use the code. I mean, in case you find anything relevant, you want to download it, you want to unlock any of these special classes, you can rather go with for this code. This code will help you unlock these special classes. And in case you want to go for the plus subscription directly, I mean, what more can you ask for? Then also you can use the code, right? Okay, in terms of Unacademy, let's crack it. I hope you found the session interesting. Okay, an advice for all of you: stay healthy, stay safe, and yes, please ensure that your academics is not hampered. I mean, it's not that the pandemic will bring this world to an end. We will bounce back, and obviously the studies, your career is equally important, and for that you have an academy. Okay, an academy ensures that none of his students have to suffer because of any pandemic. So stay healthy, stay safe. Thanks for this session. Hope to see you all in the next session. Probably, yes. That is all from my side. Thanks a lot. Thanks for the session. Thanks.